rare view sailboat on the sails.
Exactly. After watching this rare phenomenon, we settled in for the evening. And what did the Oiyshs do that evening?
Same thing we do every night, Pinky. Try to take over the world.
They're Pinky and the brain.
This time, it involved building rig models.
Że masz sondę, nie? I tutaj jedziemy z ustaloną siłą, nie? Mamy ustaloną siłę.
We were trying to compare the forces acting on different aspect ratio rigs.
Bermuda. To jest bardzo ważne, no bo to jest życie, ty potrzebujesz większego preloada, tak? Ty potrzebujesz preloada, no to dobra, ja też mam, tak? Powinienem mieć preloada, mój jest po prostu mniej napięty. Tylko teraz my musimy się pozbyć tego ptaszka tutaj.
Yes, we know our models and measuring equipment are not exactly precise, but we just wanted to get a feel for the difference.
Ja nie widzę więcej jak ogólnie może z dwie szerokości masztu, nie? W tym momencie. I tutaj tu w ogóle,
Kontrola jakości.
tu w ogóle wiesz, nie? Tu jest tak, że się nic nie dzieje, nie?
Okay, but what for, you might ask? Well, this is the reason. Our rigging is dying. Nice and crispy. Same here. For a while we were telling ourselves that it's gonna be fine, it's just a bit of surface rust. Until we found this. And the main attraction. We consulted a lot of our more experienced friends, and they all agreed this is not good. To top it all off, somewhere up there is a split wire. The only part that looks decent-ish is our front stay, if you don't count the fact that it's spliced. Spliced head stay? This one is holding for now. We don't know exactly how old the rigging is. What we know for sure, it hasn't been redone during our or previous owner's term, which is 11 years. To make matters worse, the only document that would suggest something was exchanged point to 2004, so it might be closer to 20 years. So we find ourselves at a crossroads. We could do what everyone does and go the classic way of buying a new stainless steel one, or go synthetic. Both routes have pros and cons. The way we see it, both options are pretty much equally expensive, all things considered, and will last the same amount of time, depending on who you ask. But where stainless is an easy one-to-one replacement and probably wouldn't require demasting, it will be more expensive in the future, requires a lot of special elements. You can see potential problems like crystallization, and it's heavy. Synthetic, on the other hand, super lightweight. If there's a problem, it's visible. An easy DIY replacement, and would be a lot cheaper in the future. It would require figuring out the conversion though, and most likely would require demasting. So, as you might have already guessed, especially if you know us a bit by now, we would much rather go the synthetic way. But Oiysh used to race, which means the rig is, well, huge, and what is called a high aspect ratio rig, which in all its awesomeness has some downsides. The loads on the rig are big, which poses a couple of challenges. The wires are 6, 8 and 10 millimeters, connected to the mast with T-ball joints, and we have yet to see TIs, the version for synthetic, that could accommodate the size of rope we would need to go with. Which means we would need to come up with a different solution that also takes into account the profile and thickness of our mast, which is 4 millimeters thick. If you're wondering why we have a section of Oiysh's mast laying around, let me explain. Or better yet, we'll just show you. This is what you call a mast splice, which means it was broken before, most likely while racing. Still goes to show what will happen if we mess up the conversion. Splice. If any of you beautiful people watching have any tips on how to deal with not seeing what you are filming in the full sun, please leave us a comment. So, one of the ways we could lessen the load would be to go with wider rigging, like way wider, using deck spreaders. That's why we were doing the rig type tests, to try and see the difference in behavior. For now though, we haven't come up with a viable solution that we would be entirely happy with, except for building a boat with freestanding masts, but that would require us to be one of those huge channels, or...
I love you, Pumpkin.
I love you, honey bunny.
Everybody be cool, this is a Rubbery!
Neither of which is happening for now. So we are a bit stuck at the drawing board, but I think we'll get there. We just need to come up with a plan and save up some money. By the way, if you have any suggestions on solutions that would involve more DIY than expensive stainless steel fittings, leave us a comment down below. We are open to suggestions. In the meantime, we decided to take care of some a bit less mind-boggling projects, like the cover for our motor. But first, a little bit of relaxing on a beautiful sunny day. And a fishing lesson from the experts. After a while, the fish and birds moved on, so the crew went back to their tasks. For some time now, we thought about creating a cover for our electric motor, mostly to protect it from water splashes coming from either the kitchen or our companionway. And we finally found the perfect donor material. Actually, almost the whole cover. It just needed slight modifications. Firstly, the support for our bearing system was in the way for the cover to fit snugly. So we checked the angles.
Jest nie ten, ale jest nie ten z tego powodu, że tu się zapiera, bo jest za długie.
Drew some references and took some measurements, not eyeballing at all. Then, all the precise measurements were transferred to the cover.
Nie mam dobrego pisanka.
With the general idea being that we wanted to put the triangular notch roughly in the middle that would allow the cover to click into place. Again, all very precisely measured.
Ciężko stwierdzić, co tu poszło nie tak. Zrobimy gdzieś dotąd, to ciężko stwierdzić.
Bartek started with the drill. And then moved on to multi-tool. With the notch done, we needed to tame the beefy cables that supply all the pixies to the motor. Most importantly, secure them from any potential chafe that the cover could cause. The way we use the motor, they usually carry up to 50 amps, but the max of the system is 400 amps, so let's just say we would rather the isolation on them stayed intact. In the depths of the starboard dungeon, I found a piece of tube that roughly matched the diameter of the cables. To jest najbliższe, 20. Ciepło było bardzo.
Gorzej, że trzeba przeciąć wzdłuż.
We would have to cut it along, so our laziness reminded us that we have a whole bunch of PVC pieces, and perhaps we could find something that involved less work. Lo and behold, the perfect piece we found. No cutting necessary. In the meantime, our supervisor was trying to tell us something. We assumed she was just being a cat, but now that I think of it, probably she knew all along it's not going to work. Even the softer welding cable could not conform to the shape of the angle.
Nie wiem do końca, czy to jest dobry plan.
So, as chafe occurs when there is friction caused by movement, instead of minimizing the friction, we went for minimizing the movement.
Drewno? 9, nie? Może nawet nie 9. Nie, jakikolwiek deseczek jest nam potrzebny.
And that was achieved by using the high-tech solution of 2 pieces of wood and a whole bunch of rope. There, problem solved. Only it turned out that the cover didn't really want to fit. So Bartek cut the tip of the bearing support. Still, no joy. Could it be we miscalculated something?
No dalej jeszcze.
No, ale kable są jeszcze, nie?
Nie, czuję tu, nie? Do kabli jeszcze jest kawałek, wiesz?
Then we came up with the fix. Just rotate it 90 degrees.
No teraz to ma jakiś sens mniej więcej, nie?
I guess the whole notch thing was unnecessary. The motor's cooling system was dismantled. Almost there. Now we needed to make space for the cables.
Jeszcze mniej.
No tak.
Ta-da! Everything fitted nicely and a tight rope held it in place. We later added some improvements that we'll show in some future videos. Nonetheless, we finally have a simple yet functional splash guard for the motor. Thanks for watching and see you in the next one.